Hey guys, welcome back to another video. In today's video, I'm going to be talking about implicit differentiation. So let's begin. So let's start by comparing implicit versus explicit. An explicit function is written as y is equal to some function of x, and you are able to directly differentiate. An implicit function is when y cannot easily be written as a direct function of x. So like y squared minus x is equal to 24. That's implicit because we have y squared and x in the same side. So in order to differentiate an implicit function, you're still able to do so if you treat y as a function of x. So y is implied to be a function of x because in some way you can write y as a direct function of x. So you say that y is implied to be a function of x, which is why implicit differentiation works. So how do you implicitly differentiate? Well, whenever the variable you're differentiating with respect to, which is usually x, does not match the variable inside the expression, you are able to use chain rule to solve it. So if you see like y or any other variable that is not x, so we have x right here, but if this variable does not match up, then you implicitly differentiate by using chain rule. So we do the same thing as if it were to be equal to x, but we multiply by dy dx, because dy dx is the same thing as y prime, and if you recall from chain rule, the derivative of f of u is f prime of u multiplied by u prime, where u corresponds to y and f here corresponds to something squared. So that's why there's a 2 right here and there's a dy dx, because that's the same thing as y prime. So we have this example where we're differentiating x with respect to t. These variables do not match up, so we're going to get this term over here. So we differentiate as normal, 3x squared, but we have to multiply by the derivative of x with respect to t, which is just dx dt. And we do the same thing for the other term, 2 times dx dt, and that's how we get that as the answer. So whenever you differentiate y with respect to x, use the chain rule as shown here, and this is like the same thing. So the derivative of y with respect to x is the same thing as dy over dx, because it's like essentially a fraction. So whenever you're using chain rule, the final term that you're going to be multiplying with will be d of like the variable that you're differentiating. So let's say it's y here, dy over the variable you're differentiating with respect to, which would be x here. So you have d dx, and that would be like the last term of that chain rule. So for example 1, we're going to differentiate both sides with respect to x. So we have x squared plus y squared is equal to 25. So we're going to differentiate both sides. So 2x, so the derivative of x is just dx over dx, but that just simplifies to 1 because anything divided by itself is 1, plus 2y multiplied by dy dx is equal to 0, because the derivative of a constant is equal to 0, which is what happens over here. So usually in these questions you're asked to find dy dx, so we will rearrange the variables to make sure that condition is met. So we have this sum of terms over here. So what I'm gonna do is move 2x to the right, shown over here, and then I'm going to divide by 2y. So now that the derivative of y with respect to x is equal to negative x over y. So the derivative of the original function is dependent on its x and y values. So it's no longer just based on x. It can also be based on y, because this graph over here is essentially a circle. So its derivative would also be based on its x and y parts. So in summary, implicit differentiation occurs whenever the inside variable does not match the differentiation variable. So you should differentiate everything with respect to x or the variable inside the question. Whenever you reach a variable that does not match the variable that you're differentiating with respect to, you apply the chain rule and you multiply by the d of the non-matching variable over dx, or the variable that you're differentiating with respect to, and then you solve for that derivative by factoring, collecting like terms, and isolating. So now let's do some practice problems. This is really similar to the one that we did earlier, 2x, because of power rule. And then you do the same thing here. You take down the degree, subtract 1, but you have to multiply by dy dx, because you can't, you have to implicitly differentiate this. So the derivative of 16 is 0. We oscillate for dy dx. We subtract negative 2x. Then we divide by 2y. The 2's cancel out, so you're left with negative y over x. As you can see, this has the same slope or derivative as the other one, because the constant does not change the equation at all. Okay, so now we're going to do the same thing, but it's negative. So it's just 2x minus 2y multiplied by dy dx is equal to 0. The derivative of the constant is 0. I'm going to move this term over here, so you have 2x is equal to 2y dy dx. So I'm going to divide by 2y on both sides. This cancels out. This cancels out. So now we have that dy for this function, or the derivative of y with respect to x for this function is equal to x over y. And that's the answer. So now we're going to do something a bit harder, product rule. So what I'm going to do is I'm going to divide both sides by 4. So now we have cosine x sine y is equal to 1/2. The derivative of this side is going to be equal to 0, but we still have to differentiate this side. So let's do product rule. So we have cosine x multiplied by sine y. So the derivative of sine is cosine y. We have to multiply by dy dx. So dy dx is the same thing as y prime. So to make this easier to factor later on, I'm going to put y prime, because writing dy dx takes a while. And then for this next term, we have to add with the derivative of this one. So we have sine y multiplied by negative sine x. Once we simplify, well, this will be negative sine y sine x. We can move this towards the 0 side, and now you have cosine x multiplied by cosine y multiplied by y prime is equal to sine y sine x. We can divide by cosine x and multiply by cosine y. So that's going to be equal to tangent y multiplied by tangent x, and that's going to be our answer. Okay, so now we have this one. So we're going to take the derivative of sine y, which is going to be cosine y multiplied by y prime, and that's going to be equal to 1, because the derivative of x is 1. So what I'm going to do is move cosine y over here, and the derivative is equal to 1 over cosine y. But we can still continue on from here. So we can use the Pythagorean identity, sine squared y plus cosine squared y is equal to 1, and we can solve for cosine y to say that cosine y is equal to 1 minus sine squared y square root. But as you can see here, sine y is equal to x, which means that square of that would be equal to x squared. So you can say that cosine y is equal to square root 1 minus x squared, which means that the actual derivative will be 1 over square root 1 minus x squared. This is how you get the inverse function derivatives, but I'm only going to be doing this for this problem. But this is like the method to proving it. So now let's talk about this one. So we have this term minus this term is equal to 10. So all we have to do is differentiate again. So you have 2x plus y. We use power rule, take down the degrees, subtract 1, multiply by the derivative of the inside, 1 plus y prime. And now we have to subtract. So this is going to be positive sine x, because the derivative of cosine x is negative sine x, but negative times a negative is positive, is equal to 0. So what we can do here is subtract sine x. So we have 1 plus y prime is equal to negative sine x over this term. So you have 2x plus y, but all you have to do is subtract 1. to both sides, and we're left with y prime is equal to negative sine x over 2x plus y minus 1, and that is our final answer. Okay, so this is going to be our last problem. So we're going to do the same thing as always. We take down the degree, subtract 1, multiply by the derivative of the inside, 1 plus y prime, and then we do the same thing over here. So you have 3 times the product rule, so we say x y prime plus y times the derivative of x, which is 1. So now we have these terms. So what we can do here is expand. So we have 4x plus y cubed times 1 plus 4x plus y cubed y prime is equal to 3x y prime plus 3y. So I'm going to move the y prime term over here. So we subtract 3x y prime, and I'm going to move this one over there. So we have 3y from over here minus 4x plus y cubed, and we're going to factor everything out from y prime. So we have 4 times x plus y cubed minus 3x is equal to 3y minus 4x plus y cubed, and we have that our final answer is y prime is equal to 3y minus 4x plus y cubed all over 4x plus y cubed minus 3x, and that is our final answer. Thank you for watching this video. I hope you enjoyed, and stay tuned for the next one. Goodbye.